Hello everyone, welcome to my next video. This video is on SDLC. So this is maybe new to some of you, may not be new, maybe something you already know about. But this will be very important because this will be in our class within our individual and group assignments that we have to pertain. One of our assignments will be a mock setup of an application, or maybe one of our existing applications that we do for that week. We'll break it down by the SDLC life cycles. So once again, this is information that's not in the book. This document will be posted on the Blackboard under the course documents, course documentation, and there's a folder called documents. This will be located in there. This right here is just a table contents. As you see, there's only 9 pages. I do an introduction SDLC, the different models, and what are models used for, and so forth. And I'll give some examples. All right, so SDLC, 2 different names for it. One is the Systems Development Lifecycle, or it could also be known as the Software Development Lifecycle. It's something I'm more aware of it from a software perspective. But it's a conceptual model used in the project management that describes the stages involved in information system development project, from an initial feasibility study through maintenance of completed application. So it's just like anything else. Say that you think of assembly lines. So for example, General Motors, or a factory that's making a product. So for example, thinking a vehicle. So when a new vehicle is being built at Toyota or General Motors or Ford, there are a series of things that happen. It doesn't happen at one spot. Maybe one section they work on tires, another section works on the frame, and so forth. Kind of how SDLC is done from a software development. It's done from one level, from the highest level to the lowest level. And then obviously the first level is thinking about introduction. What's this application going to do? What do we want it to do? The last level is putting it out in production and working on a maintenance plan. So the stages of SDLC, and these stages right here are kind of pretty much all of them are the same, but you'll see how different life cycles are different. So this one right here is planning and require analysis. So that's the first thing. So if you're developing an application, let's say that you're developing this Android app, it's going to be $1 million app. So before you go in and start thinking about what you're going to do, is you're going to plan and require an analysis that you need to do. You may need to do some research on this app. Has anyone developed it? And if they have, how can you make it more unique than what they have so that you could make sure it's beneficial to the public, to making it an app that makes money. Defining requirements. That's usually just defining what you expect the application to do from A to Z. Designing the product architecture. So that's a very important part. That architecture, as you're developing this Android app, and you need to know what layers involved, what pieces of the puzzle need to happen from architecture. Do you need to communicate from outside sources? So for an example, say that your app is using an API that's maybe in the cloud, using Amazon services. So you have to think of that architecture. So you have to think anything outside the box and anything internally. Building or developing the product. Well, that's the application code. So that's whatever your application is going to be involved with in that coding standpoint. Testing the product. That's you have potentially in a company, you have a team of quality assurance people that go in and test the product to make sure that basically their job is to break the product. If they break the product, then that's not great for a software engineer, but that way you're getting the best out of that application before it hits the market. And then the last part is deployment, market, and maintenance. You're deploying that product out to Google Play, and then maintenance is thinking about ways to maintain the application itself, if there's any bugs, or if you think about enhancements or features down the road. All right, so let's talk about SDLC models. There are various software development lifecycle models defined and designed which are followed during the software development process. These models are also referred to as software development process models. Each process model follows a series of steps unique to its type. In order to ensure success in process of software development, the following are the most important and popular SDLC models followed in the industry. There's the Waterfall, V-shaped, Interactive, Spiral, Big Bang Model, and Agile. But the ones I'm really going to focus on in this class is Waterfall and Agile. Why, you ask? Waterfall is a very popular one. It's been around for a long time, and as you'll see, I'll go into explanation of Waterfall, and I'll explain Agile, why we're going to utilize those over those other four. So Waterfall is the oldest and most straightforward of the structured and the methodologies. Finish one phase, then move on to the next. No going back. Each stage relies on information from the previous stage and has its own project plan. Waterfall is easy to understand and simple to manage, but early delays can throw off the entire project timeline. And since this is little room for revisions, once a stage is completed, problems can't be fixed until you get to the maintenance stage. The model doesn't work well if flexibility is needed in the project for long-term and ongoing. So let me give you an example of what they mean by that. So as you mentioned, remember at the top up here we discussed these sections here, planning requirements. Let's say that we've already planned, we define our requirements, we design our product. Here we are, we're step 4, we're building and developing the product. And we find out that, hey, there's something that we added that just isn't going to work. And we overlooked it early on in the phase. And now this has added maybe an extra 2 weeks of time. So what we need to do is look at our project and see how much time we have available. If we could get an additional resource to help out with the project, you got to remember they're coming in blind. So it's going to be hard to get that additional resource unless it's just a big coding standpoint and anybody could code it. But if you could allow yourself some time, maybe you're working on a task where, hey, you know what, you finished it 3 days earlier. If you could figure that out, then you could either add it within your current timeline, and it's a lot of extra work, but you also have to go and communicate with your project manager and make sure that there are extra hours available, or like I said, you have to figure a way of making it in your timeline. A lot of cases, what happens if it's over 2 weeks, probably what will happen is the project will be in a phase 2. So what they'll do is the business analyst and the project manager will allocate this information, document it, put it somewhere, so that at the end of the day, when you're implementing your application, you're already talking about phase 2, and these items will add to another phase of the project. So that's just an example of what that meant there. So here's a demographic representation of the different phases. As you see here, requirement analysis, system design, implementation, testing, deployment, and maintenance. But one of the key people that are involved with this in development within a waterfall, you have the project manager. He or she is the person that basically manages the project. They manage the time, the tasks. They work with the outside people within the group that are not directly with the group. They work with the business. The business is the person who comes to you and say, hey, I want this application developed. They work with upper management. They work with the software developers. They're working with everybody to see what's going on. System design is your architect, your application architect. Some people have an application architect, some people don't. And it also could be your software engineer. He or she is a person is developing the application and will have highly involvement within the system design. The implementation can be a various amount of group people involved. That's going to be your software engineer. That's going to be your business analyst. It's going to be pretty much everybody. Your testing is your QA. Deployment is pretty much yourself and any other outside organizations. And then maintenance is software development. So let's see if I have this here or not. Okay, I do talk about roles and responsibility, which is great. So as you see here, the requirements gathering, all possible requirements of a system is captured in a phase of documented. So basically let's say our business is the Pittsburgh Steelers. They come to us and say, hey, Jeff, I need this app developed for Steelers, and it's going to help the organization tremendously. Well, the first thing I'm going to do is I'm going to have my business analyst communicate with them, and they're going to work with them and myself, the project manager, and we're going to develop requirements, and that's this phase right here. Now, the system design is a requirement specification from the first phase are studied in phase and system design. So it helps specify the hardware and system architecture requirements. So once again, at this level up here, The business analyst and the project manager has worked with the stealers. They figured out what the requirements are, and then this is where we're kind of preparing this. It's a document saying it's going to cost X amount of dollars. This is what we need, and so forth. The implementation stage is your input from the system design. The system is first developed in a small program called units, which are basically integrated into the next phase. Each unit is developed and tested for its functionality, which is referred to unit testing. What that basically means in a nutshell is, once you're ready to implement it out into production, you're taking everything that was integrated within the unit testing, which is your QA and your BAs, or maybe BA could be the QA. Integration for testing, everything that you've developed into the system, you're basically testing it. Deployment of the system, once the functional and non-functional testing is done, the product is deployed into customer environments. That's when it's ready to push out the production environment. And then maintenance, that's the last part of it. It's basically to fix issues and patches. So for example, let's say that you push your application out there and 4 or 5 days go by, and guess what? You find out you have a bug. Maybe you have some type of system in the background that tracks these bugs. Maybe there are reviews from people that test the application, say, hey, it doesn't do this or it doesn't do that. Then you add it somewhere in a queue. A lot of people use HP Lifecycle as their tracking device. Other people use different things. There's so many tools out there. You could come up with your own tool, but you can even use Microsoft Excel. You just need a way to track what was the bug, give it some type of issue number, figure out what you need to fix it, and then note it so that you know that in this version 1.1, here's the problems, and here's what you did to rectify them, so you could push out version 2.1. All right, so roles and responsibilities. Business owner, this is the individual that owns the application. So for our example, we say the Pittsburgh Steelers are our business owner. The project manager, in this example I use, is myself. This person is in charge of running the project, working with business and external resources. The business analyst, this is the person who's in charge of being the medium between the business and the development team. Their responsibilities include typing of all requirements, developing testing, and documentation for the project. So basically, think of them as the person in the middle. So they're the person that goes over to business and says, hey, what did you just say? And then they tell the technical people, and they just communicate back and forth. What that does is it builds a barrier so that the business is talking to the technical. And as you know, sometimes technical people talk real detail and maybe nerdy from time to time. I do it a lot. And what happens is the business doesn't understand what language I'm talking. So you need that medium person to be involved. Then we have the software engineer. He or she is a person works closely with the project manager, architect, or if they are the architect, the business analyst, also known as the BA, and other team members. They'll work on projects and assign certain people within the group certain tasks. So usually they're software developers. They'll assign and mentor them. And then architect, like I said, that could be depends on how big your company is, how big your team is, how it's structured. A lot of times it's the software engineer, but in some cases it's their own person. And then QA analyst is the person that basically tests your application. So if you have any questions with that, please call me or email me and I'll explain it in greater detail. What we're going to talk about here is Agile. And I don't have the key members that are involved, but I'll let you know who's involved. It's a little bit different. So Agile is by breaking the products into cycles. So Agile model quickly delivers a working product and considered to be very realistic development approach. The model produces ongoing releases, each with small implementation changes that the previous release. At each iteration, the product is tested. The model emphasizes interaction as the customers, developers, and testers work together throughout the project. But since the model depends heavily on a customer interaction, the project can head the wrong way if the customer is not clear of what direction he or she is going. So how this how this process works is like iteration number 1, also known as sprints. They break them down in something called sprints. So you have the planning, the required analysis, the designing, the building, and the testing. As you see in the waterfall, let's say that we're working on a project in a waterfall that's 12 months long. That planning, require analysis, designing, building, testing, etc. It's going to be broken down in a couple months a piece. So it's going to go a little bit longer. But in this example, it says 2 to 3 months. It could be, it's usually 2 to 3 weeks. That's how the cycle works. So the people involved here, let me pull up a text pad and I can type this out. So let's close that out. So in Agile, you have this person right here is called a Scrum Master. Scrum Master is basically the same as a project manager. Their job is a little bit different. So the Scrum Master their job is to control the project. They're sort of like the project manager in a sense. They manage the project. They manage any roadblocks that are involved, and they see what tasks are being completed and managing that from a high level. But they're known as a Scrum Master. The next person involved is the product owner. The product owner is same as the business analyst, but a little bit different. Their role is not so much to communicate with the business and the technical staff, but their job is to document tasks that are required. Let me write this down. Document tasks that are required. Help build out the backlog grooming sessions, and we'll get into those a little bit later here. Let's see here, what else? Actually, that's pretty much it for the product owner. They own the product. Think of them as the mastermind of that product. They know how the product works from the business standpoint very well, and they play a very important role of help documenting and coming up with ideas and so forth. Then we have the software developer, and that's the same role as the developer within Waterfall, developing code. We have a QA person, and they test the application. So we have these things here called sprints. What is a sprint? Well, there's different sprints. Sprints are basically, writing this off on the fly, basically are tasks that are completed during that sprint. So for example, say there's sprint 0 and 1, I will say sprint 0, 1, 2, 3, etc. So let's say, well, let's not talk about sprint 0 a little bit because it's a little different. Let's say sprint 1. All right, say sprint 1, you have 2 weeks to develop application. So, and I'll talk in a little bit detail about, let's see here. Okay. So you have 2 weeks to develop an application. Here's how it usually works. Day 1 is a Monday. What happens on a Monday? Easy. The team and the business sit down and discuss items that is in the backlog. And we'll talk about that. Business states which tasks are more important to begin with. So basically in this thing, we come up with tasks in the backlog that are very important for us to start working on immediately. So we come up with a list of items. Say there's 4 or 5 items that we want to create, and we have 3 developers. So that meeting itself will last about 2 hours. So here it is. It's in the morning. We start at 9 a.m. to 11. We'll say 8 a.m. 8 a.m. to 10 a.m. Okay, tight. So right now we've communicated that. So the next meeting will be from, we'll say 10 a.m. Oh my gosh, I can't type. 10 a.m. to noon. This meeting right here will be a meeting between just the developer, Scrum Master, QA, and develop and I say QA and product owner. Yes. What'll happen in this meeting is they'll work out on flowcharts. So they'll develop a flow. They develop a flowchart of each task, and then assign these tasks to each person. So, for example, in this essence, what they'll do is they'll assign tasks to each developer. They'll figure out the developer will get a task and the QA person will get a task, and so forth. Well, those are only two people, individuals, so types of people who get tasks. But they'll also talk about availability. So this is very important in this area. So availability, let's say that, okay, my name is Jeff Seaman, and oh boy, can't type. Availability. Let's say that, okay, a 40-hour week, I put how many hours I can commit to working on this sprint. Let's say I can only commit to 20 hours. Fine. So that is 20 hours divided by 2 weeks, which is roughly, I'm saying that I could work, I don't know, 5 hours a day for 2 weeks. I'll tell you more about that. So I'm committed to only basically 20 hours in that sprint. So 2 hours a day, which equals 20 hours. All right. So we do that. That's on Monday. Okay. So that's taking up 4 hours on Monday. More likely, you might not get to that task. So let's say day 2 is Tuesday. What you will start having is each day you'll have a stand-up meeting for 15 minutes. These stand-up meetings will consist of the Scrum Master, developer, product owner, and QA. You'll ask questions. The questions you will ask be asked by the Scrum Master. The following. He or she will say, what did you work on yesterday? And you basically say what tasks that you've accomplished. And I could say, well, my name's Jeff, and I was working on developing this Android application, and I developed a button that allows the user to click on it and pull up the last time they logged into the system. So I'll mention that. Then the next thing that Scrum Master will ask me, what are you going to work on today? And then I'll be like, well, yesterday I was able to pull up the last time they logged in. The next part of my task is to provide the end user the ability to sync up their other products that they have on file with us. So that's what I'll say. And then the last one is she or he will say, do you have any roadblocks? Do you have any roadblocks? So, I'm only allocated for 2 hours a day. And I can say, you know what, I have this big meeting today, and this meeting is consistent of all these different people. So yeah, I do have a roadblock. So I can't commit any time to this today. You'll do this every day. So this is Tuesday, but on day 3, 4, 5, 6, 7, 8, and 9, you're going to do all those stand-up meetings. So what they're looking for in this 2-week sprint, which we're at day 8, which is the Wednesday, we're hoping to have all our code committed. I can't even type. Oh, geez, I can't spell committed. I thought I had it right the first time. Committed and ready for testing. let's say that you don't have it ready for testing. What happens? Well, a good chance is that sprint that you're working on is going to fail, and it's not going to be ready for the client to view on the next week. So let's say everything is working fine. Day 8 is perfect. We tested it. Day 9 is Thursday. What are we doing? We're just finishing up on bugs. Any bugs that were reported. On day 10, we're completed. And then what we'll have is on day 10, we'll have a meeting for about 2 hours. And it's a meeting that we include just ourselves, our product owner, Scrum Master, and the developers and QA person. And what we do is we show what we've completed, and we discuss what are items that we worked on that we could do better. What can we improve on? How can we make this better? And we'll discuss and we'll go through that. And then Sprint 2 starts, which is the following Monday. What we will have is we'll have that 2-hour meeting with the client again. But this time what we'll do is we'll show them a demo. We'll show them, even if it's 2 pages or 1 page or whatever, we'll show them what we completed. In this example, what's nice about the Agile, this is how it works. We're in second week, we've completed our process, we're starting our Sprint 2, we show the client, we're like, hey, this is what we completed. Client could come back and say, you know what, I don't like this, Jeff. I want this done over. And what we do is we take the pieces that they didn't like, we move it into a backlog item, and we pick it up at another sprint. It might not be Sprint 2, because we're going to talk about other items that we want to complete. We'll move that at another time, and so forth. One of the sprints I didn't discuss is, and then the whole cycle repeats again for another sprint. Sprint 0 is the important task. So Sprint 0 is everything that you want to get completed. So let's say that we're building a web application, for example. This web application is going to use architecture such as servers, it's going to need user access, it's going to need software, etc. That Sprint 0 might last 6 weeks. And those are a little bit different, because what you try to do is get everything from a high level, any person's access, whatever software you need, you get it completed ahead of time, so that way you don't have to run into that problem down the road. And that's kind of how the sprints work. And this right here, these steps right here that I have written down are basically what we just talked about. You talk about the backlog item, you put everything on that you could think of that's going to be involved, and you get it all at once, whatever you want to accomplish. And basically everything I've talked about is right here. So what models are we going to use in this class? We're going to talk about Agile and Waterfall. So I will expect in certain weeks I'll present it to you and say, you know, this week we're going to do this application, and we're going to use a group, and we're going to use Agile. And we'll talk later on about source code repository software that we're going to use, and I'll show you how all that works as well. And just to sum this up, this right here just shows you some of the big companies using Agile and Waterfall on a daily basis. So this document will be out in course documents, and this information I just threw out there, the tech stuff, I'll post it out there as well, just as is. So I hope you liked the demo. If you have any questions, please reach out to me, email me, and I'll be more than happy to help you out. Thanks a lot for following along. Have a good day.